Hello everyone, welcome to our presentation. We are group number 6 and our project is predicting football player market values using machine learning. My name is Mohammad Mahmudur Rahman and I am joined today by my teammates Samia Nauri Nikita and Toma Roy. To understand why this project matters, we first need to look at the modern football industry. Football isn't just a global sport, it's a multi-billion-dollar business. Every transfer window, clubs spend astronomical amounts of money acquiring new talents. For club executives, data analysts, and scouting networks, accurately determining a player's market value is absolutely critical. These numbers directly dictate transfer market strategies, wage negotiations, and a club's long-term financial stability. But here's the main problem. Historically, valuing a player has been an incredibly subjective process. It relies heavily on manual evaluations, qualitative scouting reports, and media hype. When human bias and market volatility are the main drivers of a player's price tag, valuations become inconsistent and unpredictable. So we ask ourselves, how can we take the guesswork out of this process? How can we transition player evaluation from a subjective art into an objective science? Our solution was to build a data-driven framework using machine learning. As you can see here in our code base, we utilized the extensive FIFA 23 player dataset, which contains over 18,000 individual player profiles. Each profile comes with a rich matrix of over 80 attributes, including age, overall rating, career potential, and highly specific technical skills like passing and dribbling. Our objective was to see if we could train regression algorithms to recognize the underlying patterns in these attributes and accurately predict a player's market value in euro currency. And to tell you exactly how we prepared this massive dataset in our code and the architecture of the models we built, I will now like to pass it over to my next teammate Nikita. Thank you.
Thank you, Mahmudur. Hello everyone, I am Samiha Nauri Nikita and I will be talking about our methodology, specifically how we prepared this massive dataset and the machine learning models we built to solve this problem. Before we could train any algorithms, we had to deal with the raw data. While the FIFA 23 dataset is comprehensive, it contains a lot of noise. Our first major step was a rigorous data preprocessing pipeline. As you can see here in our code, we started by dropping irrelevant identification columns like player URLs and names to reduce dimensionality. We then handled missing values using statistical imputation, meaning we replaced missing numbers with the median values of their respective columns to ensure no null data was disrupting our training. One of our biggest challenges was the financial data. Attributes like value in euro and wage were originally formatted as text strings containing euro symbols and commas. We systematically stripped these characters to convert them into standardized, usable numeric formats. Next, we transformed categorical variables like a player's preferred foot or position into numerical formats using label encoding. Finally, we looked closely at our target variable, the player's market value. In football, player values are highly skewed. A few superstar players are worth hundreds of millions, while the vast majority are worth much less. To handle this extreme variance, we applied a logarithmic transformation to normalize the distribution of the market values. Once we had a clean, scaled feature matrix, we split our data into 80 by 20 training and testing set. To find the absolute best predictor, we didn't just rely on one algorithm. Instead, we evaluated a diverse suite of 9 different regression models. We first started with foundational statistical baselines, linear regression, ridge, and lasso regression. These gave us a solid starting point, but they are limited because they assume player traits have a simple straight line relationship with market value. To capture the highly complex, non-linear realities of football analytics, we moved on to powerful tree-based and ensemble models. This included a decision tree, regressor, random forest, gradient boosting, XGBoost, and extra trees. These algorithms are excellent at learning complex interactions. For example, how a player's age and overall rating interact affect their price. Finally, we also tested a neural network, a multi-layer perceptron, to see if deep learning could outperform our ensemble models. We trained all 9 of these architectures using our process data. To tell you which model won the showdown and what insights we discovered, I will now pass floor to Tom.
Thank you, Nikita. Hello, everyone. My name is Toma Roy, and I will be taking you through our results, what we learned from them, and our final conclusions. When we tested the 9 models Nikita just talked about, we saw a clear difference in how well they worked. As you can see here in our results table, the basic linear models and the NLP struggle to keep prediction errors low. Their R-squared score stopped at around 0.97. However, tree-based models did an amazing job. They were great at understanding the complicated patterns in the football data. Both Exposed and Random Forest did very well, but our overall winner was the Extra Trees model. It had the lowest prediction errors, with a root mean square error of just 0.0520. It also got an incredible R squared score of 0.9981. But what do these numbers actually mean the football world? We wanted to know why the model gave players the prizes it did. Our analysis showed us exactly what controls a player's price tag. The most important factor were overrating potential and age. As you can see in the chart, younger players with high rating get much higher market values because clubs are playing for their future potential. On the other hand, older players with the exact same rating were valued much lower. This shows that our extra free model actually learned how an athletes' value drops as they get older instead of just looking at their current skill. While our model is very strong, we do want to mention its limits. The FIFA 23 dataset gives us great fact-based numbers, but real-world transfer fees change widely. A player's real price is often pushed up by media hype, agent deals, or sudden injuries. Because of this, for our future work, want to add we want to add outside real-world data to this model by giving the algorithm real match stats, injury histories of field info like social media popularity and trending news. We could close the gap between estimated values real-world transfer prices. To conclude, our project proves that pricing players no longer has to be guessing game based on human options. By carefully clearing our data using advanced models like extra trees, we have built a far and highly accurate prediction tool. This system gives football clubs, scouts, and analysts the facts that they need to make smart transfer choices and secure their long term financial plan. Thank you, everyone. That's all from our side.